Hi BC Calculus students. The next lesson is the interval of convergence lesson versus the radius of convergence. But I do want to first, now I know you don't have your warm-up books or anything like that, and this wouldn't be a warm-up I would check, but this problem is awesome. This is a great way to test Lagrange without really making you do a lot of work. See if you can figure it out. So maybe pause the video and see if you can do this on your own. Okay, hopefully maybe you've restarted now, and having tried this yourself, remember the word third order goes with them telling you they've used the third derivative, so that does correspond in this case with the third power. Given that the fourth derivative satisfies this inequality, what does this mean? What do you think they've given you here? If they are also asking you about Lagrange. Remember, the Lagrange error bound is the remainder after the nth order of your polynomial. That remainder, the absolute value of that remainder, is guaranteed to be less than or equal to m over the next factorial times the absolute value of the x you're trying to approximate minus the center to the next power. Looks like a 0.5. Oh no, there it's gone. So what did they remember? It is this m that takes the most work, right? Because m is the next derivative, absolute value on the interval from 1.5 to 2. Well, what did they just give you? So the remainder after the third order is less than or equal to, what is m? Over, not 3 factorial, but what? And then what's my center? Good. 2. And the number they're asking me to approximate. So we are going to find out what this number is using our calculator. So our bound is 3 divided by 4 factorial, 4 times 3 times 2 times 1, times well, we're doing the absolute value, right? So 1.5 minus 2, the absolute value of that is what? Let's store this in alpha A. Ah! So, 0.003 90625 is the worst error on what? Whatever that was. This number is the error bound. It's the worst error using, this is the maximum error using the third order polynomial to approximate the function at 1.5. So they're asking us why f of 1.5, but I don't have f of 1.5. I don't see it. But yet they're telling me that somehow I can use this error bound to show that f of 1.5 can never be -5. Well, let me go back to my calculator. And let me show you what I've put into y1. I put the third order polynomial. See that? The third order polynomial is in y1. So using the third order polynomial, that is what do I approximate? That's darn close to -0.5. I'm sorry, -5. How can I use the error bound to show that f, the actual function at 1.5, cannot equal -5? What's going on? Well, remember, this number, 0.00390625, is the worst possible error on -4.9. And remember, it's absolute value, right? So I could either add or subtract this number. So of course, if I take -0.49 and add to it, but remember, I'm trying to show that the function will never be -5. So what if I take the answer that I just had and say -4.95 blah 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 minus my maximum error using that third order. So the worst error I could have using that third order polynomial would get me to -4.96-ish, and that's the worst error. So if there is no way that the function value at 1.5 could actually be -5, right? Does that make sense? Kind of a cool question. Alright. So again, the homework that I had assigned for this day, the handout, looks exactly like the radius of convergence handout, but it asks you to do, instead of the radius of convergence, which is a number, and that number might be 0, or it could be infinity. Using the same problems, I want you to go from the radius of convergence to the interval of convergence. So the radius, remember, of convergence gives you, if your center, let's say, is at 0, and the radius of convergence is 3, you go a distance of +3 and a distance to the left of 3, and then you don't know your endpoints. So that's why you're just asked for a radius of convergence. But if I ask you for an interval of convergence, I need you to tell me, are these endpoints included or not? If they're not included, you leave them as parentheses. If they are included, you change the parentheses to brackets. So today is all about the interval of convergence, which means I need to test endpoints. Of course, you never do that for a geometric series because you already know a geometric series interval of convergence is a strict inequality. So the handout for today has exact same problems as last night, but you really have already done most of the work, because to find the interval of convergence, you first have to find the radius. So you did all of that last night. So for tonight, or for this new handout, you are just testing endpoints. You've already got the radius of convergence. So remember from yesterday, if a power series converges, the ratio test will tell us if it will converge only when you plug in the center. Boring. Or it will converge for all numbers that you plug in for x, negative infinity to infinity, or more likely, it will converge for numbers within an interval about the center. So some interval. Your radius of convergence is a value to a distance right and left of the center for which all x's within that radius will create convergence. But now we need to talk about the endpoints. That's why you have to be very careful about the question. If the question asks you for the radius of convergence, you do not have to You do not have to test for endpoints, but if they ask you for the interval, you must. So, another way I've seen AP ask this is they say find the open interval. That's another way of asking you for the radius of convergence. It means you don't have to test the endpoints. No endpoint testing. Even if they do ask you though for the radius, for the interval, you have to start with the open interval. So, I ran the ratio test on this, and I'm just not showing it to you, right? I assume that you can do this, and I'm giving you that what I found with a center of 0, right? Here's my x. So I have a center of 0, and I'm telling you that I found the radius of convergence to be 4, meaning that with a center at 0, I can go a distance of 4 to the right, 4 to the left, and I have an open interval of negative 4 to 4. But what happens if you plug in negative 4? Remember, the ratio test gives me I can plug in any number. I can plug in negative 3.99, I can plug in negative 1, I can plug in negative 0.99, I can plug in 0, I can plug in 0.01, I can plug in 2, I can plug in 2.7, I can plug in 3.999999999. All of those numbers I can plug into this power series for x, and I don't have to test anything. I am guaranteed to have a convergent numeric series. But I don't know about the endpoints. So take negative 4 and you must individually test it. As soon as you plug in negative 4 though, you don't have a power series anymore. You have a numeric series and you run your pre-cal numeric series tests on them. So I say to myself, how do I know if a given numeric series converges? I check the nth term test for divergence first. Then I think to myself, is it geometric? If so, I have a strict inequality. Then I think to myself, is it a p-series? And remember, p-series, think p for positive. P-series has positive terms. Right? 3 tests. Nth term for divergence, geo-series test for convergence, p-series test for convergence. If I have a series that is close to geometric or close to a p-series, I can use the direct comparison test if I know that my series that converges, I know converges, lies on top. Or if I find a similar series with positive terms that converges, and I take the limit of the ratio. Don't confuse this with the ratio test. And the limit is between 0 and infinity, then both series converge. Right? We can use the DCT and LCT for divergence as well, but remember we're after convergence. So I'm only listing the tests for convergence. Never forget, I'm putting the nth term test on every screen. Don't forget the nth term test. There is a ratio test, right, for a numeric series, right? I talked about that yesterday in yesterday's video. It's just the ratio test for power series without X stuff in it, that's all. What about when your terms have alternating signs? If your signs alternate, so if you have some -1 issue to the n+1 to the to whatever it is. This time it's just n+1 because I started at 1. And all of your terms here are positive, right? So if you take away the alternating signs part, if each term is positive then, and the terms are getting smaller as you go to infinity, and not only are they getting smaller, they're going towards 0, and this is the crucial part. Then your series will converge, and the test is the alternating series test for convergence. Really, if you think about this, this is, remember I always warned you that the nth term test is only for divergence. Remember, for if the limit of your terms goes to 0 and all your terms are positive, you don't know if you converge or diverge, right? However, if your terms are positive, they are decreasing, and the limit of your terms goes to 0, but you also have alternating signs, then adding all those negative terms, every other term being negative, is enough for convergence. So you can kind of think of the nth term test for convergence works as long as you have alternating signs and your terms go to 0. So all of these things come into my head, and it reminds me of Mr. Davis. I just think he's so cute. So back to our original problem. Remember, we found the radius of convergence to be 4. I want to find the interval of convergence. So I plugged in -4 and I wrote out some terms. Right? N over 4 to the n times -4 to the n. This series does not converge by the nth term test. It is alternating test too. I mean, you could also say it fails the alternating test because it fails the nth term part of it, right? The nth term test does not, right? These terms do not go to 0. Therefore, the numeric series with -4 in place of x does not converge. Numeric series, right? What about when x is 4? This series does not converge either. So my radius of convergence was 4, but my interval of convergence is a strict inequality. I tested the endpoints, and the endpoints both created diverging numeric series, so no equal signs or no closed brackets, right? Because you could also, of course, write this, the interval of convergence, this way, right? If you're asked, so in conclusion, if you're asked for the radius of convergence, then either you recognize a geometric series or you use the ratio test. Done. Done. QED. Right? Done. And your answer, if you have a geometric series, then, right, you can write an interval. The ratio test is either a number, right? The radius of, I'm sorry, the ROC is either, you can, if it's a geometric series, you give an interval, or you say the radius of convergence is a number. 0, another number, or an infinity. If you're asked for the interval of convergence, think endpoints. But step 1 is find the radius of convergence using not geoseries, right? Because you know you don't have any endpoints if you have a geometric series. But use the ratio test, get the radius of convergence, then do the hokey pokey, right? Put the left endpoint in, shake it all about, oh my gosh, sorry, the left, and then run your test. Always do the nth term test for divergence first. If your terms do go to 0, decide which test for convergence to use. Then put your right endpoint in, shake it all about, test, left endpoint test, right endpoint test. Use inequality notation or bracket to write the interval of convergence. So sometimes an interval of convergence might look like x is between, let's say, I don't know, let's negative 1/2 and 1/2. That's strict inequality where both endpoints failed. Maybe you have an equality here because the left endpoint created a converging numeric series, but the right endpoint didn't. Maybe both endpoints create convergent series, so both of them are included. Maybe the left endpoint created a divergent numeric series, but the right endpoint created a converging. So all of those are examples of intervals of convergence where you've tested the endpoints. If you look at page 521 in your book, a nice flow chart is there showing you once you've plugged in endpoints, right? After you've done the ratio test on the power series, remember that gives you your strict inequality, and then you're going to test the endpoints, your right and left. Please indicate which one you're testing. Of course, you always do the nth term test for divergence, which means do your terms go to 0? If your terms don't go to 0, series diverges. Kick out of the interval of convergence party. If your terms do go to 0, you might, right, you have to go down here and say, well, if they do go to 0, am I geometric? If it's geometric, I look at my R, my common ratio, and it converge as long as the absolute value of R is strictly less than 1. If it's not geometric, is it a P series, right? And I'm interested in convergence, so I'm looking for where P is greater than 1. If I have alternating series, if I have, if the absolute value of the terms converge, I'm going to apply one of the comparison tests or the integral test, the ratio test. The nth root test we never did. You can look it up. It's hardly ever used. Here's where they go. Exercise 73. Don't worry about this. AP does not focus on these as much. Alternating series test. If your signs alternate and your terms are decreasing and the terms go to 0, right? Then you have convergent. Right? The series will converge if the limit of the terms goes to 0, and diverge if not. Remember, you're looking for convergent. That's what we want. I like this too. If everything you've done so far, see what you can do with partial sums, consult more advanced books, or explore with your calculator. Ha! Whatever. So, example. Look at this. If I ask you to find the radius convergence, first you want to ask yourself, is this power or numeric? Power, right? So I did the radius of convergence work using the ratio test, and I got 2. What's my center? Good, 0. Right. We say this series converges absolutely on the open interval -2 to 2, because the ratio test had absolute value bars around it. It negated this alternating part because we took the absolute value. So now I want to look at the endpoints. Do they create convergent or divergent series? That means I'm finding the interval of convergence. So I plug in -2 in for x, and I plug in 2, right? So I'm checking x equals -2, and I'm checking x equals 2. When I checked them, I got the interval of convergence where 2 was not included. I'm sorry, -2 was not included, but 2 was included. How did that happen? So this is -1 to the n plus 1 over -1 and -1 to the n and 2 to the n, right? Over n2 to the n. Those crossed out. What is -1 to the n plus 1 times -1 to the n? Right? Well, 2n plus 1 is what? Always odd. So this is -1 to the n. True? Over here, canceled out, and I got -1 to the n plus 1 over n. So what is the difference between these two expressions? Right? Why is one convergent and one not? Well, I hope you can see that here by the alternating series test, right? N plus 1, these terms, right, have alternating signs, and right, this is the alternating part, and then the 1 over, then 1 technically over n have the terms go to 0. So converge by the alternating series. But what about this one? This looks very similar, doesn't it? Or does it? Right? These signs don't alternate. It's always -1 over n, which is the same thing as negative the sum of 1 over n. Right? But this is a p-series which diverges because P is equal to 1. And if you negate a P series that diverges, still diverges. Good? Some language that I'll talk some more about when we get back from break. This series, we say the series converges conditionally at 2 because the only, it's negative, I kept dropping, because the only reason the endpoint 2, right, the endpoint 2 converged as long as, and the reason it converged was because the alternating signs were there, that you had both the positive and negatives. Whereas every x in the open interval converged whether you were negative or positive because of the absolute values, right? Regardless. Absolutely. No problems. The endpoint 2 converged because it created a numeric series that converged only if the signs alternated. Negative 2 diverged. The condition of having a convergence series at 2, the condition was alternating series. I didn't have to worry about that condition for any number on the open interval, negative 2 to 2. We'll talk more about that after the break. Let's try this one. What's my center? Right? I'm going to do the ratio test to find the radius of convergence. Right? X minus 3. After I did my algebra, right? I canceled out and then I took the x minus 3 to the outside. Hey kids! This limit was 1. So there's my center of 3. And I can go to 2 or 4. Open interval at 2, open interval at 4. That's the radius of convergence. Now, I'm going to test the endpoints. So I put in 2, and when I put in 2, I got negative 1 to the n over 2n. And when I did, I got the interval of convergence to be equal the left endpoint. The left endpoint got to come to the interval of convergence party. The right endpoint didn't. Can you see why? Take this 2, put it out here. If it kind of messes with you, then you have negative 1 to the n over n. Right? And I've got my 1/2 out here. This numeric series converges by what? My terms alternate because of this negative 1 to the n portion. And then what's left, 1 over n, are all positive decreasing terms that go to 0. So converging by the alternating series. However, this series is just 1 over n, which is the harmonic series, harmonic P series, if you will. Oh, Siri keeps thinking I'm talking to her. Good. Not so bad, right? Lesson learned though, if the question doesn't ask you for the interval of convergence, don't test endpoints. You're going to do work that you're not going to get credit for. So don't forget, we say this series converges absolutely. On 2 to 4. Conditionally at x equals 2, because the only reason the left endpoint converged was because of the alternating signs, right? If that was in the inside of, if I made that absolute value, that was inside the absolute value bars when I was running a test, I would get divergence. The absolute value bars have to be removed in order for me to have the alternating signs and get convergence. Okay, so I hope that cleared up some of your questions. And go again and revisit your handout and look at the key that I've got online for the interval of convergence homework problems. When we get back from break, we are going to have an AP problem on the Tuesday we come back. I was going to do it on Wednesday, but I want a little bit more time for review for the test, because Thursday we're moving on to new material. Okay? Have a great break. See ya.